Welcome back to my channel, Steady with me, Steady with Collins. And today we'll be taking this example from operations research using linear programming, the corner point method. So the question is, consider a company that produces two main products, X and Y. For every unit of X it sells, it gets a 10% contribution to profits, and for Y it gets a $15. Sorry, that was $10 contribution, and Y $15 contribution. There are some limitations on demand and on product capacity. Suppose they must, by contract, sell 50 of X and 10 of Y, while at the other end the maximum sales are 120 of X and 90 of Y. Unfortunately, they have only 40 total hours of productive capacity per period, and it takes 0.25 hours to make an X and 0.4 hours to make Y. How many should they sell each in order to get profit? So now with this question we can derive our objective function from this, from here. That is, for every unit X it sells, it gets a for every unit X it sells, it gets a $10 contribution, and Y it gets $15 contribution. So this will help us to know our objective function. So our objective function will be 10x plus 15y. Now let's solve. So the 10x plus 15y now becomes our objective function, because in order for us to maximize profit we must write down our objective function. Let's write down our constraint. So our constraint will be from this is our constraint. You might be wondering, how did we get our constraint? That is, X is greater than or equal to 50, Y is greater than or equal to 10, X is less than or equal to 120, then Y is less than or equal to 90. Then the 0.25X plus 0.4Y is less than or equal to 40. That is our equation 5. You might be wondering, how did we get here, or how were we able to derive our constraint? Now let me explain. So coming back to the question, reading from here, suppose by contract, they must by contract sell 50 of X and 10 of Y. So must by contract sell. So by a contract we are supposed to sell beyond 50. So it's 50 or more for X and 10 or more for Y. So suppose by contract we are selling 50 or more of X and 10 or more of Y. That is how come we got our first constraint. That is, X is greater than or equal to 50, and Y is greater than or equal to 10. Then let's proceed. While at the other end the maximum sales are 120 of X and 90 of Y. So the maximum sales that you can achieve for a product or for x is 120. So it's either you sell 50 or more, but don't exceed 120. That is our constraint, and we all understand what we mean by constraints. Restrictions yes. So that is how come we got the x is less than or equal to 120, then y is less than or equal to 90. Then let's come to the equation 5. So unfortunately, they have only 40 total hours of productive capacity period, and it takes 0.25 hours for x and 0.4 hours for y. That is it. So 0.25 for x, 0.4 for y, and that is how come we had a point. So because we are dealing in hours, so hours, x hours, y hours is equal to total hours. So 0.25 hours x plus 0.4 hours y is equal to 40 total hours. That is how come we had our constraint. So after writing down our constraints, the next thing that we have to do is to change all the inequalities to equal to sign. We are going to change. So after changing them to equal to sign, already we can get points already, because the corner point method is for you to get points then plot them. So already we have our x point to be 50 and 120, and y to be 90 and 10. But let's focus on the equation 5. With the equation 5, we can't just derive the x and the y values just like that. So what we have to do now is to equate the x to 0 in order for us to find the y value. So we equate the x to 0, then we find the y value, and we are getting 100. Then we equate the y value to 0, then we solve for x, and we will end up getting 160 for x. So we would have another point, and that is 160 then 100. So after getting all your points, the next thing that we have to do is to plot them. So already we have this graph. After plotting them, so we have x to be 50. There was no y value, so we represent it with a straight line. Then we have x to be 122, no y value, so a straight line. Then when we come to y2, we have y is equal to 10, so straight line, no x value. Then y is equal to 90, straight line. But let's focus on the equation 5. With the equation 5, we had both 2 points, that is for x and y. So the x we had 160, then for y we had 100. So we plot our point, then we draw a line to join the 2 points. And for us to find, so after doing all this, we have to find for our feasible region. And how do we find our feasible region? For us to know our feasible region, we have to consider the inequalities, the direction of them, the direction of the inequalities. And we can see, let's take them one by one. For x is greater than or equal to 50, and this is this line. X is greater than or equal to 50. This is this line, and it is pointing, the inequality sign is pointing towards which direction? It's pointing towards this direction. That is why I have used these orange lines to indicate them that they are pointing towards this direction. Then we move on to y is greater than or equal to 10. So y, we have the y value, and it is pointing towards this direction. So if you follow the inequality, So if you follow the inequality signs, you will be able to arrive at, or you'll be able to know your feasible region. After knowing our feasible region, we have to get the point, because the assumptions states that the maximum or the most optimal solution will come from the corners of the feasible region. So we have to know the points of the various corners. Yes, we have to know the point of the various corners of the feasible region. And so looking at this corner, we can know that our point will be 10 and 50, right? And let's check this corner too. So by inspection, we can know that it's 120 and 10, right? 120 and 10. Then we move on to this corner. Because our graph was not drawn to scale, we can't know. So unless we solve them simultaneously using the fifth equation, and the x is equal to 120. So already we know that x is equal to 120, so we can insert 120 into equation 1. Then we will be able to know the y value, and we will end up getting 25. Yes, so now our points becomes 120 and 25. So we have 3 points now. Now let's focus on the fourth point too. So this fifth equation, the first fifth equation, that is 0.25h plus 0.4 equal to 40, is intersecting with the y is equal to the x is equal to 50. So we know our x value, then we insert it into the equation, and we are getting 68.78, and that becomes our y value. So now our point, the feasible region, and we know our objective function, that is 10x plus 15y. So what we are supposed to do is we insert the point into the objective function, and with the first point we end up getting 650. Now it's a positive result. It means profit because it's not negative. Then 120, then 10 to, we are getting 1350. It's also a positive result. Then 120 and 25, after inserting it into the objective function, we are getting 1575. That is also a positive result. And the last one, we are getting 1531.2. All the 4 points of the feasible region gave a positive outcome. But in this case, operations research seeks to achieve the most optimal solution. So between the 4 points, which one gave out the best or the high value? 120 and the 25 gave the highest value. So we can conclude by saying the company must sell 120 of x and 25 of y in order to achieve a maximum profit. Yes, so that is the conclusion. Thank you. I hope you enjoy the class.